So let's look at this transistor, semiconductor device which are made of the combination of two types of semiconductor to transfer a weak signal from the low resistance circuit to a high resistance circuit. So basically this transistor, you no need to remember it. It will not ask you to define what is a transistor, but normally it's about the calculation about the type of transistor. So when we see this diagram here, we have two different symbols, or we have two different types of transistor. One is NPN. I'm sorry, I just want to check for the chat box. So one is NPN, another is PNP. So if you still remember last time teacher asked you how to remember, always we will refer to this arrow. So the arrow will show us what type of the transistor it is, because collector, base, emitter, it is the same. The only difference is the arrow, and how we remember that, remember from positive to negative. If you're able to label the middle one as positive, then you know that this is NPN. The other way around, same. Here will be P, go to N, always follow the arrow P to N. Then this one will be PNP transistor. Okay, so all the while in our exercise, we always base on one type of transistor only, which is the NPN. Very seldom that in the question will give you PNP. But even if it is given you PNP, but the concept is still the same, just that the direction of the current flow is the other way around. So number 3, diagram 5.91 shows two different types of transistor, which is PNP and NPN. There are 3 connections in the transistor. So where we have base, we have collector, and we have emitter. So here we have base, collector, and emitter. And for an NPN, we will see that the current will flowing from the top and then pass through here and then going down. Okay, so basically what is this? If we look at here, we have middle, which is the positive to negative. You will see this side, actually it is a piece of diode, and the other side is also another piece of diode. So means we have a diode like this, and then we have another diode like this, opposite, and here is the junction. Okay, so whenever there is a base current flow to, so means whenever the current can oppose this flow to, then it will let the current to flow through from the top as well. Okay, so therefore, if we want to start a transistor, we must connect B to the circuit. If we just connect to terminal, it will not going to work. Okay, so the base of is connected to the positive terminal, and the emitter is connected to the negative terminal, and the arrow of emitter shows that the direction of current flow as shown in this diagram. So the current flow from top go to the bottom. You can imagine this 6 volt and 0 volt, it is the battery, positive 6 volt, and then the bottom one is 0, okay, negative side. Okay, so this is just showing that 6 volt and 0. So diagram 5.21 shows an NPN transistor in 2 different circuits. So the first circuit is considered the transistor is off. Always remember, we must connect this part here, only we can start the transistor. So as you can see in this diagram, it shows that the transistor is on, and the battery need to connect to positive, go out. Okay, always remember the current is from positive flow to negative. If we have IB, then IC will flow to. When IC will flow to, this light bulb can on. Okay, so I just want to highlight why we need to have a transistor, because in the electronics, normally the current is very small. But in the electrical part, normally the current is higher, much higher. To turn on a motor, we need high power or high energy to do it. Okay, so therefore we need to do this type of switch using a small current to switch on a big current. So the bulb does not light up when there is no base current, as shown in diagram 5.21a. So if we do not have any connection at this part, we will not going to have any IB. Okay, so this IB must be there, only we have IC. So diagram 5.12 shows that the light bulb light up when a small current is flowed to the base of the transistor. So as a conclusion, we need to get IB, only we can get IC. And what is the relationship? If you still remember, last time we learned about the series and parallel diagram. Whenever we have these two water pipe joined together and become one, so therefore here IE will be total. So imagine if this is equals to 10 ampere, this is 0.1 ampere. So what is IE? These two joined together will be 10.1 ampere. Okay. So this is the total current or IE that we can get. So when IE come to this junction, what happened? Then it will split back 0.1 ampere here, split back here, 10 ampere, return back to the side. Okay. Just before the junction, it is sum out of the value. So let's look at the bottom here. A PNP transistor can operate in the same way, but the base and collector current have to flow in opposite direction. So means the IE will be going like this, and the IC will be going like this. So if let's say we have a light bulb here, and then we have a battery, the battery, remember, the long side need to come out with the current. Okay, so it will return this way. It can be both sides, either the top or the bottom. Okay, so it can be going here and return. Okay, so but we need to have another battery also long short like this. Okay, so yeah, let's proceed to the next page here. So you can see this is NPN transistor circuit and this is PNP, and these two diagrams try to compare each other. So what's the difference? As teacher said, the battery direction is different and the current direction is different. Okay, so therefore here is going in this way, and this is going this way. This is going in this way, and this is going in this way. But it is the same concept. Okay, so the transistor circuit of the base current and emitter circuit. So the similarity is this, and the base circuit need to have a minimum voltage to switch on the transistor. The characteristic of this transistor switch is known as circuit is known as a switch. Okay, so when we have a small IB current in the base circuit, can control a large current on the emitter output circuit. Okay, so I think here is typo. Therefore, this transistor is known as the amplifier circuit. So remember the function of transistor, where the first function is used as amplifier. Amplifier means we amplify, we magnify the magnitude of the current. So the resistor RB connected to the base should be large enough to limit the base current. So as you can see here, we have one RB, same equal to this RB. If the question asks you, what is the purpose for RB? If the question asks you, what is the purpose for RB? This is to protect the transistor. If without this RB, the current come will be very large. It may burn the transistor. Therefore, we need to put a resistor here to limit, to reduce the current come to this transistor. Therefore, it will not burn the transistor. Okay, so in the exam, you can write that it is used to protect the transistor by limiting the current flow to the transistor. Then you get the full marks. Okay, so what's the difference between these two circuits? The collector terminal is connected to positive VC. As you can see here, it is VC, but here is the negative side. Okay, so the collector is connected to the negative VC. Emitter is the other way around. Here is negative side, but here is the positive side. So the base is just different in terms of this direction as well of the battery. Okay, so that is the main difference. Other than this, everything, the operation is the same. So just now we learned about the first function of this circuit, that it is amplifier. So if you still remember, we have something called I gain. Okay, so it is missing in these notes here. I gain is equals to what? IC divided by IB. Okay, so we'll use the current here divided by the small current, the large one. Then we'll see that how many times it is higher. So for example, here is 1000, here is 10. Therefore, we'll have 100 times gain means 100 times it is higher than the base current. Okay, so this is the function of amplifier. So second function is about voltage divider method or potential divider. So normally we also call this as potential divider, which is more appropriate because of voltage. Voltage is like the unit, okay? So a minimum potential difference must be applied to the base circuit to activate a transistor, and this can be achieved by potential divider that consists of resistor R1 and R2. So before that, I just have a look. No. So as you can see here, a minimum potential difference must be applied at the base circuit to activate the transistor. This can be achieved using a potential divider that consists of R1 and R2. So again, last time teacher explained to you, what is this potential divider? It is just similar like ignore the middle, just similar like we have R1 and then we have R2. And this R1, R2 is connected to a battery. Okay, so and then come back, we know that this magnitude or the value for R1 and R2 will determine what is the voltage at V1 and also V2. Okay, so if let's say we have 3 volt and this is 5 ohm and 5 ohm, we know that as long as the unit or the value of this resistance it is the same, then these two will be divided by 2. So we'll get 1.5 volt and 1.5 volt. Okay. So if we have some voltage here, means V2, we have some voltage, only we can allow the current to flow to in this direction. Okay. So only we have IB. So therefore, as explained here, we need a minimum potential difference must be applied to the base circuit here to activate the transistor. So in order to direct the base current IB, this IB, and activate the transistor, activate this transistor, the potential difference across the base V2 must achieve a minimum value. So here we must get a minimum value. So what is that value? We don't know. Okay, so it should be a fixed value, just like the startup for the diode. But here, all the while we didn't know about that, and it is not important to know. Okay, so why not important? What is more important is this formula. Okay, so this formula you can see V2 equals to R2, V1 plus V2 plus R1 plus R2. So if we look at the circuit at the top here, what is the total resistor? We know that in a series, we'll just add these two together. Okay, if you want to know voltage in V1, we'll use R1 divided by the total voltage. Okay, so in another word here, if you want to know V2, it is total voltage, and then this is R2 divided by total resistance. Okay, total resistance also equals to R1 plus R2. Total voltage is also equals to V1 plus V2, because in this case, V1 plus V2 equals to V total, and if it is in series, okay, parallel means from the top until the bottom, it will be sharing the same voltage. If it is 3 volt, means from the top here, if I have another voltmeter, number 3, come to the bottom, we will also get 3 volts. Okay, so let's move forward. If you see all this, because we are just using Ohm's law, we are not talking about the internal resistor or EMF. So please don't use that formula to calculate. Okay, so the internal resistor formula is not applied here. We are just using the normal Ohm's law formula in this case.